board is around the corner. How many of your board exams are going on? Maybe about to get over? Please let me know. And if you guys are in 11th and still watching this, do let me know about that as well. And my name is Shreyas. I'm your physics master teacher. And today we are going to do in this one shot ray optics. And this is Zero to Superhero series, which is going to make sure that you know all the concepts, how to apply the formulas, and also see how to use them in the real life application as well. So let's begin with the class. And those of you who do not know me, that's me, and you can get to know more about me on my Instagram handle, and you can definitely read it out as well. And in today's lecture, we are going to see the reflection laws, then we are going to go to plane mirrors, then spherical mirrors, then we'll go to refraction, curved surface refraction, lenses. I will take up the optical instruments and prisms part in some separate class, because we can deal with it separately as well. All right, so let's get ready. Yes, Selva is ready already. Hello Kanmani, Venkat, welcome, Vaishnavi, hello Hari Krishna. So my dear warriors, remember that in this Zero to Superhero series, I am first of all conducting all the important classes which is required for your term 2 examination, because that's on the plate now. We need to finish these things first, and once your board exams are done and you guys are all comfortable with most of your term 2 syllabus and it's all over, then we can concentrate on 11th and the 12th term 1 syllabus as well. So let's begin, and you guys are ready too. And I'm pretty sure you would have hit the subscribe and also showered your love by smashing the like button. Also, a quick reminder for all the students who want to ace in the NEET examination. We have the NEET Ekalavya batch, which is a unique batch at Vedantu, which trains and nurtures kids who have crossed at least certain benchmarks and certain limits, and push themselves till a certain amount of marks. Now if you are confident of your basics, or if you are sure that yes, I am ready to take one step further, then this NEET Ekalavya batch is exactly for you. Remember, this batch is free, and the NEET exam is the entrance test for this batch is going to be conducted on 2nd of May 2022, and that too at 2 o'clock. So very easy to remember the date. Remember, this is where you will get entry into the NEET Ekalavya batch. We also have the JEE Ekalavya batch, but the entrance for that is now closed. You have to wait for some more time before the next entry point begins. And in this Ekalavya batch, it's not just about 12th standard, but also the 11th standard, and you will have the best teachers who have produced the topmost ranks in the country. These teachers are so good that you can just rely on them completely for your complete A to Z preparation for your NEET examination. And these classes also have doubt solving along with assignments, test series, and these test series are very unique, which will help you improve your marks and analyze your mistakes. So go ahead with this and make sure you register for the NEET examination, the NEET Ekalavya batch examination, which is going to be conducted on 2nd of May. All right. You'll also get special tips and strategy sessions along with board preparation. So all of this is going to happen in the NEET Ekalavya batch. So let's start with reflection. Yes, if you are a NEET dropper also, Vaishnavi, you can listen to this. Hello Hari, welcome. Hi Navya Teja. Hello Farhanatu. Nice to see you all over here. So the NEET Ekalavya batch is also for droppers, Shruti. You can see that there will be a link in the description box. Make sure you open up the Ekalavya link and register for the test. You will get the test link. You have to join the Telegram group, and that's how you register and get entry into the batch. All right, so let's begin with the class. Hello Anisha, Rajshekar. Good evening, all my lovely warriors. So let's talk about reflection. We all know that when light rays fall on a reflecting surface like water surface or your mirror, they get rebounded back and they follow certain laws, and the image formation can be found using those laws of reflection. Obviously, we have seen these laws again and again. You have seen this in 10th standard, but a quick recap. This is the incident ray, this is the normal ray, this is the reflected ray. All the three rays are in the same plane, And the second important point, the angle of incidence is equal to the angle of reflection. That's standard. All angles are measured with respect to the normal. That's your laws of reflection. Now, whenever you talk about, ray optics, it's all about geometry, it's all about finding the image, or it's all about finding where the object is to form that image, how is the image, all of these things are dealt with. So, like the name suggests, ray optics, so you also need to understand that an object can emit different kinds of rays, and that will also help you understand what kind of image will be formed. Like you can have a parallel beam, you can have a divergent beam, you can have convergent beam of rays. Beam is a collection of rays. If the rays are parallel, then most probably they never meet. And if they don't meet, that means they will not form an image. I hope you understand. Or maybe the object is so far that the rays, by the time they reach you, have almost become parallel. So either the object is very far, or the image is never formed because the rays are parallel to each other. These rays can be formed out of an object or because of a mirror or a lens. So the rays can converge because of a lens, they can also converge because of a mirror, or maybe these rays are coming out of an object, that's why they are divergent in nature. So you can have all these kind of beams which can arise due to different lens or mirror formation. Now, there are simple rules to locate the image, and the rules are so important because sometimes even without solving the numerical problem, you can just draw the ray diagram and figure out where the image is and then tick mark the option, because at the end of the day, it is an objective exam. So, what are the rules for image formation? Very quickly. It might be deleted by devil, but it is there for NEET and JEE, so we have to see this. Thank you, Mohammed. I'm very good, Killer Dare. Good evening, Mansa. Nice to see you back. Hi, Kavyasri. Hi, Parthiv. Hi, Mohit. Welcome aboard, all the lovely warriors. So, first of all, you need to have at least 2 rays. You need to have at least 2 rays to locate the image. Only when you have 2 rays which meet at a point or appear to meet at a point, that's where you can locate the image. Even if you get a 3rd ray, I know it will meet at the same point, so I don't need the 3rd ray. Light rays, after they fall on a flat surface, should follow the laws of reflection, not just flat or even uneven surface, or even uneven surface also they will, or even uneven surface they will follow laws of reflection. As in, if you have a surface like this and the ray falls this way, if you draw a normal here, they will reflect and this angle will be equal to this angle. If a ray falls here, again if you draw a normal, again it will reflect, this angle will be equal to this angle. So it is valid for even curved surfaces, that's what you need to remember. Okay, image formation takes place where the intersection of the light rays occurs, like you can see over here. When the rays meet, basically all the rays, wherever they are meeting, that's exactly the location of that particular image. And if the reflected light rays meet physically, then the image will be real. But if it doesn't meet actually, then the image will be virtual. Like in this case, the rays actually meet. That's where the image is real, meaning if you hold a screen or if you have a wall, then on that wall you will see the rays will converge and you will see a crisp image of that particular lens or mirror formation. And you would have seen this kind of arrangement in a cinema hall or a movie theater. So there is a projector, probably even in your school. So what happens behind the projector? There is some film which is being played and the rays converge on a sheet or a paper or a screen or a cloth. So that's where the rays converge. That's where you get real image. Virtual image are those images where the rays appear to meet but they don't actually meet. So I have some beautiful diagrams to explain you what these images and objects are. Observe this. This is the real image. Remember the example of a projector. Remember the example of a projector in your school or movie theater. You need a screen over here. You need a screen over here to see it. So this is your screen so that you can make that image formed on that screen and you can see it clearly. Virtual image are those images where the rays appear to meet, like I just said. So like you can see, the rays are not coming actually from here. Only when you extend the rays backwards, that's when it is coming from. Example, your normal mirror. You stand in front of the mirror, the image is formed behind it. It feels as if the rays are coming from behind. Actually, the rays are probably originating from here. They are just getting reflected. They are coming here, they are getting reflected. Only when you extend it backwards, that's when you see that the rays are meeting at a point. So this is a virtual image. Is that clear? Alright, yes, these notes are enough, Bacha, Surendra. Now, if you see clearly over here on this side, you have something called as real object and virtual object. Many people forget about this definition. Guys, the definitions look very, very similar. Look at this. The arrow marks are meeting. The rays are meeting. That is a real image. A real object like this pen or me. I am a real object. I am not virtual. I am actually present here. It's not my ghost which is here or some holographic image which is here. So basically, from a real object, you will see the rays actually originate. Like the rays actually terminate, which produces real image. If the rays actually originate, it's a real object. But if the rays appear to meet, then that is a virtual object. The rays don't actually meet, but they appear to meet. That's when it's virtual. Notice the difference. Over here, the rays are coming out of it. So it will enter your eye. That's when you will feel that the image is formed here. Right now, understand the rays are going to meet here, appear to meet here. So here, this is the location of the object. After reflection, when they enter your eye, that's when the next image will be formed. Is that clear? Yep. So when you stand in front of the mirror, it's virtual. If you see something through your spectacles, that is also virtual image. It's not actually there. You feel that it is there. Okay. So most of the lenses, most of the times will produce virtual image. All right. So what are the different characteristics of the image which is produced by a plane mirror going to be? Yes, let's write it down one by one. Come on, if you know any of the properties, start putting it up in the chat box. Let's see how many of you know all the properties. Put up all the properties that you know regarding a plane mirror. First of all, the object distance. If the object is at a certain distance, the image is also at the same distance. So object distance is equal to the image distance. Everybody knows this? Object distance is equal to image distance. If the pot is of this size, the image of that pot is also of the same size. So object height is equal to the image height. Okay. Also, if that object is real, like the pot over there, the object is real, the image is going to be virtual. Next, you can see if the pot is erect, even the image is erect. So yes, the image is always going to be erect in nature. Now, there is one more thing. Now, the pot does not have exactly left or right per se, because maybe it does not have feelings, or it does not have brain, or you cannot differentiate left and right clearly. But let's say a human being is standing over here, it has left and right. So the image which is formed inside the mirror is laterally inverted, meaning if that person in the mirror were to be a reality, then if you're a right-handed person, the duplicate which is formed inside the mirror will be a left-handed person. Yes, exactly. If you use right hand for eating, that person will use his left hand for eating. That's how it is. So it is called as lateral inversion. So there is no inversion height-wise, but there is inversion laterally. The images are like left and right inverted. Yes. Hello Ishwar, long time. Okay, very good, excellent. Now the deviation formula for a mirror. The rays which fall on a mirror, if they are falling at an angle of incidence I, they get reflected over here. The rays wanted to go here, but they ended up going here. So this is the intended path, this is the actual path, this is the deviation. This delta is basically your angle of deviation, and this delta happens to be 180 minus 2i. Keep this in mind. This delta happens to be 180 minus 2i. Next thing, yes, this is for JEE, and Dasri, this will help you build up the major concepts. After this, if you want to build up on more concepts, then you can watch that specific subtopic. No need to watch the entire chapter, bacha. Now, if you rotate the mirror, if the mirror is rotated, rotate the mirror by, angle theta, then the reflected ray rotates by an angle of 2 theta. This is your reflected ray. The reflected ray rotates by 2 theta. This is very, very important concept. Next important concept that you should know is when you have two mirrors inclined at an angle, let's say this is theta, and you see that there is some ray which falls on the mirror, gets reflected and gets reflected like this. This is incident, first reflection, second reflection. The total deviation of that ray, the total deviation of the ray which is reflected twice is given by 360 minus 2 theta, and it does not depend on the angle of incidence. It only depends on the angle between the mirrors. Yep. Yes, this is needed for term 2, bacha. Yep. So listening to concepts and doing problems both, Shyam, depends if your concepts are clear. If you know that you can solve at least 5 to 6 problems out of 10 problems, if you pick random 10 problems, then you should just do problems. But if you can't, then you should listen to theory, especially one shots just before the exam, and then go to the problem solving part. And if you feel that still more input is needed, then watch that particular specific subtopics theory only. Alright, so this is very important formula which you should know regarding deviations. Alright, next thing is regarding the image velocities and object velocities. If you see that there is a mirror and the object is moving, then even the image will move, and there is a very peculiar relationship between them. Now, an object might have multiple velocities. Say for example, an object might be moving with a velocity VO bar like this. That velocity may have two components. One component is basically the component which is perpendicular to the mirror, and you have another component which is basically parallel to the mirror. So one component which is perpendicular to the mirror, other component which is parallel to the mirror. Then you will see that the image on this side will also have components, and the image velocities, if this is the image velocity, the image velocity parallel component will be exactly equal to the object velocity's parallel component. Meaning, if the object goes with 2 meters per second like this, the image over here behind the mirror will also go with 2 meters per second. There is no reason for it to go slower or faster or in some other direction, because always object distance is image distance. If the object is here, image should be here. If the object is here, image should be here. Object is here, image should be here. So always you will see that the object and the image will move parallel to each other, along the mirror surface. This is one of the component. Second thing, the perpendicular component. If the mirror is here and the object comes with certain velocity, you will see that the image with respect to the mirror, will also come or move with the same velocity. So hence, I would say that the velocity of the image in the perpendicular direction relative to the mirror is exactly equal to the velocity of the object, again perpendicular to the mirror, again relative to the mirror over here. So the relative velocity is the same with respect to the mirror. If you come with 3 meters per second, this will also be 3 meters per second, but in the opposite direction. Hence, when you are putting a bar symbol over here, you should also put a minus sign. Is that clear till this point? Shall we now move to problems? Is this point clear, my warriors? Because now we are going to see some problems after this. Yep. Thank you, Barlin, Laishram. Thank you, Surinder. All right. So, yes. All right, Mohit. Great. Perfecto. Let's start with some questions. This is a simple question. Everybody should spam the answer now. Okay. I want to see everybody's answers in the chat box because this is a warm-up question. I want to really make you, burn like fire because you're going to light the paper, be it boards, be it CET, be it JEE, be it NEET. Okay, here's the first question. The plane mirror produces a magnification of -1, +1, 0, infinite. Come on. This is very simple. Everybody is getting warmed up. Perfect, White Devil, Anisha, Shyam, Kavyasri, very good. Salva, very good. Kanamani, Divya, excellent. Everybody is getting +1. Actually, the answer is +1 because plus signifies the image is erect, minus signifies the image is inverted, 1 signifies the image is of the same size. So yes, the image is of the same size and it is erect. Okay, let's see how many of you can solve this. I want the similar spam in the chat box after reading the question. Not more than 30-40 seconds for this. A plane mirror makes 30 degrees with horizontal. If a vertical ray strikes the mirror, find the angle between the mirror and the reflected ray. Yes, Mohit, you got +1, +4. All right. So what is the correct way of solving the question? Obviously, draw the diagram first. Without drawing diagram, it is going to be a little bit difficult. So this is our mirror, and I think it makes certain angle with the horizontal, and it is given to be 30 degrees. Now, it is also mentioned that there is a vertical ray which strikes the mirror like this. So if it strikes like this, I think I need to draw the normal as well. So the normal to the mirror will be like this. This is the normal. Perfect. So what's that angle which it is making? Guys, if this is 30 degrees, you know that even this is 30 degrees. Two parallel lines, one line which cuts through it, alternate angles, this is 30. If this is also 30, then obviously this is 60. If this is 60, then this is 30. Correct? If this is 30, this is 60 because they are perpendicular. And if this is 60, this will be 30. Again, complementary angles. So the question is find the angle between the mirror and the reflected ray. So where will the reflected ray be? Reflected ray will go like this. This is your reflected ray. And what will this angle be? If this is angle of incidence, this will be angle of reflection. Hence that will be 30 degrees. Got it, everyone? So now, what is the angle between the mirror and the reflected ray? Mirror and the reflected ray. This is the angle. Come on, this is 30, this is also 30, this is 30, this is 30, this is 60. Hence the answer should be 60 degrees. And do we have such an answer? Option C. All of you are wrong. All of you are wrong. Oops, oops, oops. It's a big oopsie. Okay. Look at that, guys. That's why you should attend the classes over here. Understood? So be very careful. This was a geometrical based question. And at the beginning of the class only, I told you ray optics is all about geometry. It's all about finding images. It's all about visualization. It's all about those rays and following the rules. Got it, everyone? Perfecto? Understoodo? Clearo? Amazingo? Okay, let's move on to the next question coming up on your screen. If a person is chasing a mirror, he's a mad person, he's chasing a mirror which is moving at 5 meters per second with a speed of 2 meters per second, then the relative speed of the image with respect to the person is, let's see. Perfecto, Kaveshri. Let's move on. So let's see how many of you can get the next question on your screen now. So there is a mirror over here and that mirror is moving with what speed? It's chasing a mirror which is moving at 5 meters per second. So the mirror is moving at 5 meters per second. The person, this is the mad person, we'll just call him Pandu. And Pandu is chasing the mirror with a speed of 2 meters per second. So the question is, his image relative to him will be at a speed of, let's see how many of you can get this. Hello Gautam, Bacha, welcome aboard. So in my college, 11th is running when I start Fusion, sir. You should start on your own. Don't wait for your college because college is independent of JEE and NEET preparation, bacha. Alright, so first thing that you should do is find the relative speed. Think carefully, visualize. if I am Pandu or you are Pandu, you can visualize whosoever you wants to be Pandu, and there is a mirror over here. Now the mirror is moving with 5. With respect to the mirror, what will be the Pandu's velocity? With respect to the mirror. So with respect to the mirror, mirror is moving faster, Pandu is moving slower. So the difference of their velocity will come. Hence 5 minus 2 is 3. So with respect to the mirror, Pandu will appear to separate out. So Pandu is chasing but he is not able to catch up. He is falling back. So he will fall back at 5 minus 2, which is 3 meters per second. Everybody agrees with this fact? Alright, perfecto. But that is not the answer. Many of you are writing A. Nope. Now Pandu's image here will also move with 3 meters per second. Will also move with 3 meters per second with respect to the mirror. I just told you in my explanation, in my formula concept, application part, that over here only, the velocity of the object with respect to the mirror is equal to the velocity of the image in the perpendicular direction. This is your perpendicular direction. Velocity of the image in the perpendicular direction. It's the same, but in the opposite direction. Yes, so we just got it. If this is here, that will be there. So the question is relative speed. So what will be the relative speed? Pandu's image is going with 3. You are going with 3. The relative speed will be 3 plus 3, which is nothing but 6. Hence the answer is 6 meters per second. Perfecto. Very good, Muhesh. Very good, White Devil. Excellent. It is not 7. It's not 7. Be careful. I hope you guys understood. It is not 3 meters per second either. Okay, so what was the concept? Always remember, sit on the mirror and observe everything. Because when the mirror is at rest, things become easy. And that's the reason why you have learned relative motion back in 11th grade. So that you can simplify complex problems which otherwise could be difficult, sitting in different random frames. So sit on the mirror, problems become easy. And you should know when to add and when to subtract. Be careful about that. Perfecto. Moving on to the next question. If two mirrors are inclined at 60 degrees with respect to each other, then a ray which gets reflected by both the mirrors will be deviated by how much degrees? 60, 120, 180, 240. Come on, let's see how many of you can spam the answer in the chat box before I complete the question. Very interesting. I just gave you the formula. Two mirrors inclined at an angle, and the question is what's going to be the total angle of deviation. Figure it out. What should be the correct answer? Some of you have started writing the answer. Very good, my warriors. Alrighty. So whenever you have two mirrors inclined at certain angle, in this case it is 60 degrees, then whatever ray comes, doesn't matter what the angle of incidence is, the total deviation of that ray was just given. I told you it is 360 minus 2 times of angle of inclination between the mirrors. So in this case it is 360 degrees minus 2 into 60 degrees. 60 into 2 is 120. 360 minus 120 is 240 degrees. Hence option D is correct. Oh, very good, Shruti. Very good, Naz. Excellent, Rohit, Shyam, Kanmani. Very good, Anisha. Very good, Kavya Shri. Excellent. As some of you who did not get the previous questions, I'm pretty sure you're happy to know that you got this answer. Keep it up, guys. You have, passed level 1 at least by attending today's class. Now let's go to more and more stages, more and more levels. The next thing that is going to come up is spherical mirrors. And spherical mirrors are nothing but plane mirrors which are bent. They will follow the laws of reflection. Obviously, it's not like they will disobey. But think of a spherical mirror as multiple small plane mirrors. Now, there can be two surfaces that you can talk about. The one which is bulged out, that will be the convex surface, like a spoon. I'm pretty sure when you don't get food and your mom is also angry at you, then you're just waiting at the dinner table, looking and staring at your disappointed face in the spoon. And then you might start wondering which side is better. Do I look better on the convex side or do I look good on the concave side? And the funny part is when you are on the concave side, your image turns out to be inverted And when you're on the convex side, then the image is erect. Look at that. Yashika, I'm very good. Yes, very good, White Devil. Okay, so there are logical explanations to that, and the explanation comes from the ray diagram, of course. Yes, the explanation comes from the ray diagram. So Shyam says that his face looks better in the convex side, not on the concave side. All right, and guess what? If you have a concave mirror, you can look at your tooth and you can find out if you have been eating a lot of chocolates and if your tooth are decayed. Because when you are on the concave side and you see the image, you can figure out if there is some tooth decay. Basically, the image is magnified, and that's what dentists do. That's what dentists do. Okay. So anyways, we'll come to that. So convex and concave mirrors. So you have a lot of applications, like convex mirror is used near the turns or near the parking area because it has a wide coverage area. Also, it's a good field of view. So all the objects tend to form their images within that small range. Also, the images are virtual and erect. It would be very weird if the images are like inverted or something else. Then you will be confused whether it is coming from left or right, up or down. So good thing is it is erect. All right. So now the different points obviously about a mirror you should be knowing. So you have the focus and the center of curvature. Now remember one thing, for a concave mirror, the focal point is in front of the mirror. Obviously, if the rays are parallel, the rays converge in front of the mirror. But in case of a convex mirror, the rays never converge. The rays diverge, but they appear to diverge from a point which is behind the mirror. And this side, left side, is negative, right side is positive. That's why you will always see that if you talk about the focal length for a concave mirror, the focal length for a concave mirror, it will be in negative. That side is positive. So focal length for a convex mirror will be positive in value. This C is the center of curvature, meaning if you extend this spherical surface, it will become a complete sphere. This C happens to be at the center, so it obviously has a radius of curvature. Same thing over here as well. Okay, this is the radius of curvature. And is the focal length and the radius related? Yes, it is. The radius is equal to twice the focal length, always, for a concave or a convex mirror. Yeah, very, very important. Or F is R by 2. Okay, I hope this is clear, my warriors. Yashika, I will let you know, bacha. Probably you can leave a comment after the session or towards the end of the session. I'll talk to all of you. I want to, continue with the flow. Ankit, welcome. Hi, Sonmati. And no, Mohammed, that's not me on the spoon. It's some random dude on the internet. All right. So moving on. The rules, very, very important. Very, very important. The rules of forming the image. So starting with a ray which is parallel to the principal axis passes through the focus in case of concave mirror, or it appears to pass through the focus when extended for a convex mirror. Why are these rules important? Remember, I just told you that you need how many rays? 2 rays. For what? For forming an image. So when you know an object and you want to find its image, you need 2 rays. And to get those 2 rays, you can't just draw random rays. You will only get confused. So better to follow these rules, which will easily help you locate the image. Next rule, if the ray passes through the focus, it becomes parallel. If the ray appears to pass through the focus, it becomes parallel. Actually, it's an extension of this rule. If the ray goes like this, parallel, and then goes like that, if you reverse the arrow mark, obviously reversing the direction of the light does not change its path. The path will still be the same. It will retrace the same path. It's just that the arrow marks will be inverted. Okay. No problem, Hari. You can watch it from now. Instead of not watching the entire other 2 hours, it's better to miss that half an hour and watch it later on, Hari. In case, my warriors, you are joining in a little bit late, it's okay. Watch the remaining part later on, but don't miss that part after the class is over. Last point, if the ray passes through the center of curvature, it comes back through C. It points towards C, it comes back on the same path. It retraces the same incident path. That's only for center of curvature. Keep this in mind. Now, you need to practice this for your boards and for JEE and NEET exam. Try this, don't just by heart. If you guys are going to sit and by heart this table, that will be the biggest mistake. Or you better visualize, oh, it is at infinity, the image will be formed at the focal point. When the object starts coming closer, then the image starts moving this way, and when you are at the center of curvature, the image is also at the same size and it is inverted and it is real. And when the object starts going closer, then the image starts going towards infinity, and eventually the image comes back behind the mirror when the object comes between the pole and the focal point. So between the pole and the focal point, it is enlarged, it is virtual, and it is erect, and this is the exact property which a dentist uses to check your tooth. He places a concave mirror such that the tooth is between pole and focus, and the image is enlarged, it's virtual, and he can see the enlarged image of the tooth. I hope this is clear. I'm so glad, Ankit. So same thing for convex mirror also you should know, but for a convex mirror, always the image is virtual, it's diminished, and it is erect. So nothing great over there, especially for convex mirror. Keep this in mind, okay, my warriors? All right. Now, regarding the sign conventions. See, very important for you to know, many people by heart this as left side is negative, right side is positive. That is not correct. Okay, up and down, positive, negative, everybody uses, that is fine. The problem is by hearting left is negative, right is positive. That's not correct, because what if the mirror is like this? And sometimes even things can go crazy. Even if the mirror is like this, maybe the other side is positive. It depends, guys. So better way to do all these sign conventions is looking at the direction of the incident ray. Be it a mirror or a lens, doesn't matter. Be it a mirror or a lens, the rules are the same. If the incident rays, this is the incident rays, doesn't matter where the reflected rays are. Incident rays are going like this. Then look at the arrow mark. See where it is going. It's going like this, right? Then make this as the origin. This is your origin, and this becomes positive side because it is going that side, and this becomes your negative side. That's how it is. So the positive and negative sides are decided by the direction of the incident rays. If for some reason the incident ray, if the incident ray is like this, then this will become the positive side and this will become the negative side. So keep this in mind. Always look at the incident rays, doesn't matter, don't care for the reflected rays. Okay, I hope this is clear. Okay, I hope this is clear. All right. Yes, is there a bit of guarantee? I can guarantee, Sham, there will be one question at least, and most likely even two questions in your JEE or NEET examination. Guarantee. Okay. Now, what are the mirror equations? What are the mirror formulas? Let's have a look at it one by one. First of all, U is the object distance, V is the image distance, F is the focal length, okay, and R is equal to 2F, I have already told you. So first formula, the mirror equation is 1 by V plus 1 by U is equal to 1 by F, where R is equal to 2F. This is one of the equation. All right. The second equation which you should know is the power of a mirror. The power of a mirror, not many people know this. The power of a mirror is nothing but 1 by F, but the sign is very important. Okay, I'll tell you one thing. If you take a concave mirror, concave mirror, is it converging or diverging? Concave mirror, the rays goes, merges, it accumulates at a point. So it is definitely converging. If it is converging mirror, then definitely a concave mirror must have positive power. Concave should have positive power because it is converging. Focal length for a concave mirror is negative. The focal length for a concave mirror, it has negative focal length. So how do you make this number positive? By multiplying it with a minus sign. Hence you get a plus over here. I'll repeat. For a concave mirror, focal length is negative. Now negative into negative will make it positive. So the power will be positive because I know the rays are converging. Whenever rays converge, it is called positive power. When the rays diverge from that instrument, it is called the negative power. So it works even for convex mirror. The focal length is positive, hence the power will come out to be negative. I hope this is clear. I hope this is clear. No white devil derivation is not needed. Okay, it's not needed now. All right, now just time has gone for derivations. Time has come for applications. Time has come for now formulas, usage, concepts, definitions. This is the time right now. Okay, so this is another important formula which you should know. Power is -1 by f. The next formula which you should know is magnification, which is perpendicular to the principal axis. Basically, it is the image height. It's the image height upon the object height. And that formula is -v by u. Another important formula. Image height by object height. So this is image. How many times is the image as compared to the object? If m is negative, if this is negative, it means it is inverted. Okay, it is inverted. And if it is positive, it means it is erect. Keep this in mind. Okay, that's all it means. The another magnification that you need is the longitudinal magnification, which is along the principal axis, meaning how many times does it get expanded along the principal axis, and that is your image width upon object width along the principal axis, and that is minus of v square by u square, which is also the image velocity upon the object velocity. This is velocities. Very, very important formula which is again coming up on your screen. How many times does it get magnified along the principal axis depends on v square by u square with a negative sign, and image velocity upon object velocity also has the same formula. Is that clear? Ankit, this is for session term 2 only because all these topics are there for your term examinations. Okay, so refraction through curved surface will also be done, Muhesh. Okay, cool. So let's start with some questions, and here comes the first question on your screen. Where should a person stand straight from the pole of a convex mirror of focal length 2 meters so that the image is formed and it is half of its original height? Let's start solving the question. So what do we have? We have a convex mirror. So this is your convex mirror. This is the person over here. He should stand over here somewhere. All right. Now I don't know where he is standing. Is it given? Where should a person stand? No. Focal length is given. The image is half of its original height. I know if the object is here for a convex mirror, the image will be formed over here, and the image will definitely be erect in nature because it's a convex mirror. For convex mirror, always the images are erect. So the magnification, the image is half, magnification will be plus half. The plus has come because it is erect. Keep this in mind. Magnification is, minus v by u. Keep this in mind. I just gave you the formula, minus v by u. So therefore, v is equal to minus of u by 2. I got v is negative u by 2. Now the whole idea is to find out the value of u. So I cannot just use this. I need one more equation. I think I will use the mirror equation. What is the mirror equation? 1 by v plus 1 by u is equal to 1 by f. What is 1 by v? V is minus u by 2. So I'll put minus u by 2. That 1 comes here. Plus 1 by u, I don't know. And this is 1 by focal length. Focal length is 2 meters. It is going to be a positive focal length because the focal point will be here. So this is the positive side. So 1 by 2. So therefore 2 by minus u and basically minus 2 by u. Oops, just one second. Let me get this out. Yep. So minus 2 by u plus 1 by u. So it will be minus 1 by u is equal to 1 by 2. So therefore u is equal to minus 2 meters. And do I have such an option? Minus 2 meters? Yes, I have it as option D. Yep, that's correct. It's not C by chalo, it's D. It is D. Yes, Naz, you will get. Definitely. And thank you, Naz, for guiding all the new warriors to or the correct videos as well as the playlist. Fair enough? So what were the concepts used? First, convex mirror forms always erect image. Hence the magnification is positive. Next, it was given to be half. So use the formula minus V by U. You get the relation between V and U because you want to find U. V is not given. So you found V in terms of U. Substitute it here and then solve it. You will get the answer. That's it. As simple as that. Moving on to the next question. Is object distance in any case positive? Very interesting question, Mohit. I'll just answer your question before going to the next one. Is object distance, is it possible that it is positive? I'll give you an example. Imagine you have a convex mirror example, and let's say the rays from an object are coming like this. They appear to converge over here. This becomes your virtual object. This becomes your virtual object. You can see the rays, incident rays are going like this. Hence, this side should be positive. Hence, in this case, the object distance will be a positive number. So, many people feel object distance is always negative. No. It depends. If the rays are converging, it forms a virtual object. Okay, I hope this is clear. Sync shadow, V by U is the formula for lenses. So for lenses, same formulas are there, but just a difference of the sign. The sign is different. Okay, I'm going to come to lenses also, sync and others. Okay, Yuva, I would suggest you should start it as soon as possible. The more you delay, the more constrained it will be towards the end. Okay, if you have time, if you can manage time, start it. But if you think, no, my 11th is only messed up, I need to first finish those 11th, school exams properly, then you do 11th, or else you can start it right away. Okay, a real object is moving at 4 at a distance of f from the pole of a convex mirror in front of the convex mirror. If the focal length of the mirror is f, then the speed of the image is. Interesting question. Let's again try to draw the diagram, visualize it, and then start solving the question. So this is your principal axis, that's your convex mirror. Object is moving at 4 centimeters per second in front of the mirror. Okay, so this is where your object is. Let's say it is moving at 4 centimeters per second and it is at a distance of f. The actual focal point will be over here. Okay, what is the speed of the image? In order to find the speed of the image, this is what we need to do. Image speed by object speed is nothing but magnitude wise. If you forget the minus sign, okay, you can forget the minus sign. It is nothing but v square by u square. V square by u square. I know u is f, it's f. I don't know v. So to find v, I need the mirror formula. So let's do this. So let's use mirror formula, which is 1 by v plus 1 by u is 1 by f. So 1 by v is not known. U is minus f because object is on the left side. This is your negative side. This is your positive side. The rays go like that. So this will be minus f is equal to 1 by f. Therefore 1 by v, shift it over there. 1 by f plus 1 by f is 2 by f. Therefore invert it. V will be equal to f by 2. Substitute it over here and let's see what do we get. Let's substitute. Image velocity, I do not know what it is, but I definitely know the object velocity is 4 centimeters per second. So put it over here. Image by object, image is f by 2, image is f by 2 and object is f. So this square by this square, this is nothing but 1 by 4. Now 4 and 4 gets cancelled. Do you see that? 4 and 4 gets cancelled. Do you see that, my warriors? 4 and 4 has just got cancelled right over here. So what will happen? What will be your image velocity? Image velocity will be 1. Image velocity will be 1. No, it is not 2. Be careful. Yes, be careful. Object. Yeah, it is not B, bacha log. It is option A, 1 centimeter per second. Okay, how V and U square? Oh my God, why did I do square? Now no, I'm fine. Yeah, it is fine only. There is no problem in that. I'll just go back. See this formula. When you're going along the principal axis, then V by U square is there. Image by object velocity is minus V square by U square. So V by U is only for height. It's only for height. For this side, along the principal axis, it is square. It is fine only, bacha. I hope this is clear. Is that clear? Is that fine? No, it's not a mistake. It's fine only. For once, looking at your confidence only, you know, I sometimes start thinking, my God, did I do something? Okay. So, Suganeshwar, for 12th standard students, already my 12th standard Pathfinder playlist is there. So, for 11th, we called it Nurture. For 12th, we call it Pathfinder. It's there. All the chapters, right from electrostatics, ray optics, wave optics, everything is there. Don't worry, Suganeshwar. Start watching that. Okay. Nandana, someday, maybe in some gupshup talk. Alright. Okay. Will we complete whole of ray optics white devil? No. Like I said, we will be doing, you know, except for, what is that? Prisms and your optical instruments, everything else we will be doing. Okay. So let's start with the next question, which is, oh, the answer given here was 2. This was wrong, guys. It should be 1 centimeter per second. Ignore that. Okay. Just ignore that. Alright. Now the next question is, the next question is a thin rod of length f by 3 is placed. Oh my God, this is going to be interesting. Placed along the optical axis of a concave mirror of a focal length f such that its image, which is real and elongated, just touches the rod. The magnification is, this is crazy question. Let's start with the diagram, of course. And a thin rod of length f by 3 is placed along the optical axis of a concave mirror. Interesting. So we have the concave mirror. Okay. And this is the optical axis, such that one end of the rod just touches the rod. So if you have a rod and imagine this is the image, but they are not at two different places. One end touches this end. That means if this is the object, this is the image, both are along the principal axis. That means the object and the image are formed at the same place, and that can only happen for one point. Thank you, Berlin. The class started Aarti at 7 o'clock. Every day, 7 o'clock, Shreyas sir, live on V Enlite. Where is that point? There is only one point, my dear warriors. It is going to happen at the center of curvature. Correcto. So, exactly at center of curvature. So, let me just show you the object and image, I feel. So, let's say this is your object. So, this is your object. Its length is given. The object's length is f by 3. And center of curvature, we all know that it is at a distance of r. And r is twice the focal length. So this is twice the focal length. I hope everybody agrees. And the image is formed right over here. This is how the image is formed. The question is, what's the magnification of the rod? Nilarjan, just replace that t.me in the telegram link with telegram.me. It will work. Okay, try that out. How to do this? I just need to know the length of the image. But to know the length of the image, I need to know where is this point. Okay, let's say we call this point B. And let's say this B is formed because of this point A over here. If I know where B is, I can find the length and then I can find the magnification. To find B, I think I need to know where A is, because A's image is B. A's image is B. So where is A? We can figure that out. If this is 2f, if this is f by 3, naturally this distance will be 2f minus f by 3. 3 2s are 6, 6 minus 1 is 5. So this will be 5f by 3. Everybody agrees with this point? Okay. Oh, is it, Sonalika? Just leave a comment after the video ends, then I will definitely help you out. But this object distance will be negative because it is on the left side. We'll take care of it. Now, let's use the mirror formula, which is 1 by V plus 1 by U is equal to 1 by F. 1 by V, I don't know. U is object distance for A. A is on the negative side. So this is minus minus 5f by 3 is equal to 1 by f, of course. Shift it on the other side. So let's see what do we get. 1 by v is equal to 1 by f is common, and you will have 1. But the focal length is also negative. The focal length of a concave mirror, remember, is negative. So I should put a minus sign. So minus 1, and I will have this minus going there as plus, and this will be nothing but 3 by 5. So this will be 1 by f, and you will have 3 by 5 minus 1. So it will be nothing but 3 minus 5 by 5. So which is nothing but 1 by f minus 2 by 5. So that's 1 by v. Therefore, v is equal to minus 5f divided by 2. Yes, minus 5f divided by 2. Is that clear, my warriors? That's what you get. Now, once I know v, what is this v? V is the image of point B. This is for point B. This is for point B. So, can you find this length? What is the image length? Obviously, the image length will be, this is 5f by 2 from here to here. This whole distance is 5f by 2. So what will be the image length? 5f by 2 minus 2f. This will be 5f by 2 minus 2f. How much will that be? 5f by 2 minus 2f. 5 minus 4 is 1. So it will be just f by 2. So I got the image length. I know the object length. I think we can figure out the magnification. So the magnification will be image length, which is f by 2, upon object length, which is nothing but f by 3. So ff goes, 3 goes on the top, 2 comes below, which is 1.5. 1.5 should be the answer. And do I have it here? Yes, that's option D. Is that clear? Yes. Aniline V Enthuse is now called as V Enlite. Don't get scared. You're on the right channel. So we had a channel called Elite, and obviously you are on Enthuse. So Enthuse, Elite merged, and that's why it is called now as Enlite for JEE and NEET both. Is that clear? Understoodo? Perfecto? Great. Option D is perfectly correct. Let's see how many of you can solve the next question. If a real object is placed in front of a curved mirror and it produces inverted image, then the image must be real, image must be virtual, image can be virtual or real, and it is not possible. Okay. Ringtone world, very good, bacha. Okay, but it's not about figuring out from which book it is, it's about solving it, even if you have seen it before. But good, you answered it. All right. Let's see how many of you can do this question. Rajshekar saying D, Kanmani saying B, Arun saying C. We have different opinions over here. Wow, India is a land of unity in diversity, truly. Vidhi also saying A now. Nightmare saying A. Anisha saying A. Interesting. Oops, what just happened? Okay, yeah. So, if a real object, now real object means object distance will be negative, is front of a curved mirror, produces inverted image, means magnification is negative. Okay. Is there a formula relating magnification and object distance and maybe image distance? Yes, there is. Magnification is minus V by U. Now this M, it is clearly seen from here, M is negative. So this is a negative number. This U is also a negative number. This minus and this minus cancels. This minus and this minus cancels. So V should be negative for sure, so that the equality is balanced. So that the equality is balanced. Does it make sense? Or think of it like this. Negative by negative, positive. This minus remains. If LHS is negative, RHS must also be negative. As simple as that. Now, what does negative V mean? Negative V means the image is formed. The image is formed in front of the mirror. So if this was your mirror, if this was your object, the image is also formed here. That means the image is real in nature because the rays will converge onto it. So the image must be, there is no doubt about it, it must be real. And all of this analysis came not with ray diagrams, but with a simple formula which is of magnification. Very good. Very good. Neat spot, you have all my blessings, bacha. Don't worry. Very good. Hello, Vandana. Very good ringtone. Moving on to the next. And let's talk about curved surface and plane surface refraction. So let's talk about refraction. So we all must have probably seen this experiment, like you dip, or pour some water in some bowl and you can have some object which is immersed. You will see that as you pour water, the object starts coming up and up and up. It feels like magically it is being elevated. So actually speaking, the rays of light are bending, and that's why it gives you the perception that it is starting to come up and it's starting to levitate. But actually, it's not coming up, it's just the rays which are bending. Yes, the ray optics chapter is also there in 10th, and you have the more slightly advanced version in your 12th standard. So if you have done your 10th well, you'll also be benefited in your 12th standard. Now we all know when rays go from rare to dense, like air to water, the rays bend, and if the rays go from water to air, they bend away from the normal. And Snell measured the angles of incidence and the angles of refraction for different, angles and for different pair of media, and from that he gave the Snell's law. So not just the angles, but even the speed of light changes. You will notice that when the light changes the medium, the speed of light also changes. And you have seen this fact even in your electromagnetic waves chapter. Any electromagnetic wave changes its speed the moment the medium changes. In fact, if it goes to a denser medium, it will become slower. But there is one thing which does not change. And that is the frequency. Whatever is the frequency, that frequency remains the same. It never changes. All right, Priyanshu, I'll remember it. Then, what doesn't change, Arun? Frequency. Yes, light is an electromagnetic wave, correct, Jayant? But we know speed is frequency into wavelength, or wavelength is speed by frequency. So, if frequency doesn't change and speed changes, naturally the wavelength must change. So, as soon as the medium changes, frequency never changes. Like you can see, the wavelength will change. If the speed slows down, if V decreases, the wavelength will also decrease, like you can see. So this is a beautiful example of a ray of light which is going from air to glass, or air to diamond, or air to water. It slows down, wavelength decreases, but frequency remains the same. See, frequency decides the color. So basically, if a green light enters water, green light remains green light. It does not become purple or red. So frequency remains the same. That can be seen naturally even if you see a ray of light passing or changing mediums. Okay? Or rather, Jayant, you should ask, why is electromagnetic wave light? Or, think of it this way. Light is just a special part of the entire electromagnetic spectrum. Okay? Think of it that way. Light is just a small part. You just end up seeing a small part. That's why you usually associate, light, it's electromagnetic wave. But there are other kinds of waves you can't see. Microwaves, X-rays, etc. If you could see that, it will be a wonderful thing. Okay, you will be very astonished. But you can't see all of these things, number one. And all the other things which you can't see have same properties, but fundamentally, like their energy of photon is hf, wave speed is frequency into wavelength, all these things are same. They have electric field, they have magnetic field, but they can produce different effects like diffraction, how they diffract, and can they ionize the gases, and their applications, the range, all that depends on which category of electromagnetic waves we are talking about. Okay, now talking about the angle of incidence, angle of reflection, speed of light, the formula of Snell's law. Let's see this. So Snell's law, if light goes from medium 1 to medium 2, 1 mu 2, which is also referred to as mu 2 by mu 1, is nothing but speed of light in medium 1 upon speed of light in medium 2. is going from 1 to 2. This is medium 1, this is medium 2. It is mu2 by mu1. This is the only catch or change here. It's mu2 by mu1, but otherwise it is c1 by c2. Speed of light in medium 1 upon speed of light in medium 2, which is also sine of the angle in the medium 1 upon sine of the angle in the medium 2, which is sine r. This is how it is. Also remember one thing, 1 mu2 is reciprocal of 2 mu1. If refractive index of water is found with respect to air, then the refractive index of air with respect to water is the exact reciprocal. This is what you should know. Alright. Also remember, since speed of light is directly proportional to the wavelength, hence this is also equal to lambda 1 by lambda 2. This is because f is constant and anyways the f value gets cancelled out. A big equation which you should know. Okay. Aarti, I'll definitely try bacha, but trust me, recording that 15 minutes took me almost half a day. Okay, so it's surprising, but not many people know it, that recording a shorter video takes longer time than recording, or not recording, just taking a class like this. Yeah, but I will try, because everything has to be perfect. The content, everything, I can't say random things, right? Or I cannot interact with students. So it takes a lot of time. Okay, now comes the next part, which is light going from rare to dense and dense to rare. There are two important things which you should know. First of all, we see that when light goes from rare to dense, speed decreases, right? The light bends towards the normal, correct? The wavelength decreases. That's from rare to dense. And no matter what angle you incident, you will see the light will always go to the other medium. Even if you come from this side, it will come here. Even if you come from this side, it will come here. Even if you go here, it will come here. It always goes to the other medium. It always refracts. That's the first thing. The second thing is here. If light is going from dense to rare, if the light goes from dense to rare, then there is a problem. You can't make the light go from any angle. Meaning, look at this. If the light comes like this, then yes, maybe it will refract and go to the other medium. Maybe even when the light comes like this, it bends and goes to the other medium. Now I have started to see the problem. As I increase the angle of incidence, I can see that most likely if I make the light go like this, incident at this particular angle, huge angle, maybe there is not enough room for the light to refract. It cannot refract, it just comes back at the same angle. It basically gets totally internally reflected. And this only happens when light goes from dense to rare medium, not from rare to dense. From rare to dense, it can always come out, keep this in mind. From rare to dense, it can always, oops, 1 second. From rare to dense, it can always come out. So if it goes like this, it will probably come this way. If it goes like this, it will again come this way. If it goes like this, it can again come this way. So all the angles of incidence are possible. Only for dense to rare, there is a particular range of angles possible, and that maximum angle for which the light goes to the other medium is called as the critical angle for that given pair of medium. So what is critical angle? Critical angle is that maximum angle of incidence in the denser medium for which the light enters the other rarer medium. Beyond that critical angle, like the red one, the light is not able to enter the rare medium, it just gets reflected. I hope this is clear. Sonalika, you can let me know, bacha, whatever your question is, I'll definitely answer it. Okay, look, and there are many applications of total internal reflection, like, optical fibers. Look at this laser beam of light. The light ray enters into this glass tube which is very dense, and because it is dense, it is not able to enter into the rare medium. It is getting totally internally reflected, and that way this light ray just keeps on getting reflected in the tube and goes to the other side, and there are no losses because nothing is coming out of the tube. There is nothing which is coming out of the tube. So this is one beautiful application of your total internal reflection. There are other many examples of total internal reflection which you can find it in NCERT or even in my detailed classes. So this animation is also very nice, which tells you how total internal reflection occurs. Look at this. This is denser medium, that is rarer medium. if the angle of incidence is increased, usually refraction also occurs, reflection also occurs, but beyond a certain angle, that's it. No refraction, only reflection occurs. And the critical angle formula is something which you should know. Sine of that critical angle is 1 by mu. Very, very important formula. Mu of the denser medium with respect to the rare medium. Mu of the denser medium with respect to the rarer medium, which is like normal. For glass it is 1.5, for diamond it is 2.4, for water it is 4 by 3 or 1.33, and so on and so forth. Thank you, Venkat, so much. Yeah, Arun, there is a question coming on it. Shh, hold on, that's why I'm not deliberately telling it. What about density of light in total density of light? There is nothing like density of light, bacha, white devil. I'm pretty sure you're mistaken, or you wanted to ask something else, I guess. Hello, Ashwin, welcome aboard. Okay, let's start. Let's start with some questions now. Total internal reflection is possible when light enters from. Come on, this one is simple. When light enters from, total internal reflection is possible. Okay, I think even optical density, I'm guessing. So what was his question? Where did it go? What about density of, or optical density in total internal reflection? So white devil, if you can rephrase the question, probably I can help you out. Okay, what are other people saying regarding this option? Okay, most of you are saying B. Somebody is saying D as well. All right, no, it is neither B nor D. Okay, total internal reflection is possible and light enters into glass from air. Guys, what happened? What happened? Niranjan, start watching my lectures. Trust me, you will find it easy. What does this statement mean? Enters into glass from air. Guys, from air into glass is not possible. Total internal reflection needs dense to rare. Be careful. Enters into water from air. Glass, water, both are dense medium. How is it possible? Enters into glass from water. Water to glass. Water has refractive index 1.33. Glass has refractive index 1.5. So if we go from here to here, there will be no total internal reflection. It can nicely go. It's not from dense to rare, it's from rare to dense. And water and enters into water from glass. Enters into water from glass. Dense to rare? Yes. Understood? Got it? See where you made the mistake. Always read carefully. Okay, this was a language question, I feel. A person goes from this point to this point. So you should understand where are you starting, where are you ending. Okay, let's move to the next question. Hello Jai, nice to see you back. And the next question is about critical angle of the medium with respect to the vacuum is 30. If the velocity of light in vacuum is this much, what is the velocity of light in the medium? Okay. Is the intensity. What about the density of light? I think, White Devil, you meant intensity of light. Well, the intensity of the light, so what happens if 100 joules of energy is falling per unit time, per unit meter square, under normal circumstances, 40 might get reflected, maybe 60 might get refracted. But when total internal reflection occurs, everything gets reflected, assuming there is no absorption. But if there is some absorption, there will be some loss. But otherwise, complete energy will get reflected for total internal reflection. So the intensity of incidence will be roughly equal to the intensity of reflection. Yes, Muhammad, confusing with denser and rarer. Okay, let's see. Many of you are saying B, some of you are saying C now. Okay, Venkat, just eat some nice medicine. It will remove all that headache, and get nice oil massage from someone. That's it. Oil massage helps. Usually when I get headache, I get oil massage done. It's very relaxing and soothing. And then, or else have hot water bath nicely. Okay, or take a nap for 15 minutes, 20 minutes or half an hour. Usually the headache goes away. So let's try this question out. The critical angle is given. So sine of IC is 1 by mu. That's the formula. So sine of 30 degrees is 1 by mu. So sine 30 is half, which is 1 by mu. Therefore, mu is equal to 2. Now, once I get refractive index, we can find the speed of light. So speed of light in vacuum upon speed of light in the medium. is nothing but your refractive index. So speed of light in the medium is speed of light in vacuum, which is 3 into 10 to the power 8 divided by refractive index, which is 2. So this is 1.5 into 10 to the power 8. So that should be option B, of course. Yes, Kavyasri, yes, Raj Shrikar, perfecto. Okay, so sometimes two concepts, Snell's law and your critical angle, both concepts are combined in one question. Moving on to the next question. Okay, this everybody should spam. You should not even hesitate. And guys, let me tell you, when you put up the answers, even when you're wrong, no, it makes me happy. Because I can see that, because you made a mistake, I know that you have learned this concept. If you don't type, no, then most likely I will never know whether you're learning or not. It's okay to make mistakes. Nobody will judge you, including me, on any of the Enlites present here. Because we are warriors, we are bound to make mistakes. Only when you make mistakes, you will learn. Fine. Which of the following is an example of TIR, total internal reflection? Optical instruments, Aarti, my lecture is there. In the playlist, you can watch optical instruments. It's just barely one lecture. So I would say watch optical instruments from that class. That will be better. Okay? It's just going to take you 1.5 hours or so. It's there in the physics playlist. Watch that. Yeah, well, Mary, you need to also give NEET, mock test. Also, you need to give assignments, more questions, PYQs. You need to solve all of that. Then it will be sufficient. Never be happy with what you're doing. You have to do as much as you can. So, total mirror, no. Twinkling, no. Mirage, yes. Thin film of soap bubble, no. It's a mirage. Mirage is nothing but, okay, I'll tell you what mirage is. See, I think most of you know this, but still, you, I don't know, maybe, yeah, you see, let's say a camel. This is a camel. Okay, you see a camel. This is a camel. This is the hump of the camel. And this is how camel looks like, right? Correct? Okay, fair enough. And this is your Pandu in the desert. So what happens is, usually in the desert, the air density changes. Okay, the air's density changes from one layer to the other layer or with height. So the rays which are coming from the camel, okay, what happens? They get bent because, you are going from, so if you look at the normal, this is the angle of incidence, this is the angle of refraction. You are bending away from the normal. Basically, you are going from dense to rare medium, dense to rare. And then comes a point when that angle of incidence from one layer to other crosses the critical angle. So the light ray just reflects and then it starts going like this. So the light rays basically enter towards it goes in all directions, but those rays which are going down, they start bending away, and then the angle of incidence suddenly reaches critical angle, and then it gets internally reflected. So when they enter Pandu's eyes, Pandu will feel that the camel is below. Pandu will feel the camel is below the ground level. He will start wondering, he will think it's a ghost. This is called as a mirage. The exact opposite effect is called as a looming. In looming, what happens? So this was a mirage. In looming, the rays which are going up, they start bending like this, and once they cross the critical angle, they get internally reflected and they enter Pandu's eyes. So Pandu will feel that the rays are coming from the top. He will feel the camel is in air. What will he feel? Because the rays are coming like this, he will feel the camel is in air. He will really freak out. He will see a flying camel in the middle of desert. He will definitely run. Yeah, so this is not great. And people have seen in the ancient times distant ships floating in air, sometimes islands floating in air, and that effect is called as looming. And people used to think there is some black magic, there is some, some crazy person has done something with their heads, but little did they know that it's all because of total internal reflection. That's it. Yeah. Oh, the camel is looking like a dinosaur? No, man, this is a camel. See, dinosaurs, okay, I'll teach you guys animals one day, okay? One special lecture on how to draw all the animals from me. Shreyas sir, will teach everything. Dogs, cats, lions. It's very simple, trust me. Okay, so moving on to the next question on your screens now. A ray of light strikes a transparent rectangular slab of refractive index √2 at an angle of incidence 45. The angle between the reflected and the refracted ray is dead man shape, flying shape, yes. Okay, so what is the answer for this question? Pandu is very cute. It's looking like a dog, is it? Oh my god. Every person has different. See, that's the beauty of my drawings. So every person starts thinking about it creatively. So, you know, or else you go to some teachers, they draw such nice diagrams. The teacher says it's a camel, everybody's like, yeah, it's a camel. But in my drawings, when I draw an animal, nobody is convinced that it is that animal. Everybody thinks in their own way. So they start thinking out of the box. What could it be? They're all waiting. It's like a suspense. Which animal has sir drawn? Nobody knows. It's like a mystery. Okay, so a ray of light strikes transparent rectangular slab. Let's start drawing the diagram. Question is not visible fully. I think it should be. A ray of light strikes a transparent rectangular slab of refractive index √2. So mu is equal to √2. Let's say this is the normal. And what is happening? At an angle of incidence of 45. So this is 45 degrees. This is where it is incident. Obviously it will get refracted like this. So this is angle of refraction. So this is your refracted ray. Obviously it will also get reflected. This is your reflected ray. The question is, what is the angle between reflected and refracted ray? If this is 45, naturally this is 45 degrees. No doubt about it. Angle of reflection is equal to angle of incidence. Next, you have to just find R. Use Snell's law. Sine of I by sine of R is equal to mu. Sine of 45 divided by sine of R is mu, which is √2. Sine 45 is obviously 1 by √2. This is 1 by sine R is equal to √2. So therefore sine of R is equal to 1 by √2 into √2 is 2. So naturally R is equal to 30 degrees. If R is equal to 30 degrees, now the only question which remains is how much is this angle theta. So theta will be, total angle is 180 degrees minus that 45 degrees minus this 30 degrees. So come on guys, 180 minus 30, 150, 150 minus 45 is 105 degrees. That's the answer. Do we have it? Yes, option C, correcto. Perfecto. Amazingo. Understoodo? Is this clearo in your heads? Very good, Nishan. Very good, Aparna. Very good, White Devil. Very good, Straight Boy. You can do it in multiple ways as well. The flying camel effect, White Devil, it happens when the exact reverse thing happens. So in case of Mirage, the lowermost layer is rare, then the medium becomes dense. Oh, sorry, correct. It was correct. So the lowermost is rare, uppermost is dense. But when uppermost is rare and lowermost is dense, that's when looming occurs. Exactly opposite. All right. So moving on to the next question. Oh, we have come to apparent depth and height. Yes, oh, sir. Oh, very good. All right. So the next thing is how, the bottom of a, let's say a lake or maybe a swimming pool appears to be more shallower. And also it's funny if you think about it, how nature plays games with so many animals. Like I'll give you an example. Imagine this girl is a bird. This girl is a bird, example. Imagine this diver, which is inside water or some liquid, is a fish. Just imagine. The rays which come out of the fish, bend and they enter the bird's eyes like that. So because they appear to come from here, the bird feels the fish is here. The bird feels the fish is here. Correct? Understood? Now, the fish, meanwhile, also is looking at the bird because the bird is going to hunt the fish. Bird is going to hunt the fish. Crazy. Okay, don't take it otherwise. Somebody's thinking, what is sir saying? Is the girl going to hunt the diver? I don't know. Maybe. Happens, right? Okay, so the girl is not going to hunt the diver. I just told you, the girl is the bird, the diver is the fish. Okay, it's not the girl. literally over here. Okay, so guys, the rays from the girl will also bend, and when the rays from the girl bend, when you extend it backwards, the fish will feel that the bird is here. So think how nature is playing games. The bird is preparing to attack the fish, but little does it know that actually the fish is not here, but it is more deeper inside. The fish is more deeper inside. And the fish which thinks that the bird is here, will get the shock of its life when it gets to know that actually it is much closer to the water surface. So that's what, happens. But the good part is, they are used to it. That's how they have been living for ages, centuries, generations. They already know it. It's there in their DNA. So they are prepared by instincts. When the fish sees the bird is here, it knows, alert, brain will tell, listen, your ancestors died when they thought like this. Don't do that. Actually, the bird is here. Be alert, run. Also, when the bird is looking at the fish here, alert, bird alert, your ancestor went hungry because he thought like that. It is there in the DNA. So then it thinks, oh, I should not think it is shallow. I have to dive deeper. And then it's a game of chances. Who wins, who loses. Yeah. Interesting, right? Crazy. So that's what nature says. Very true, white devil. And if I start marking the options, the heights, this is your actual height, or you can call it depth, whatever you want to call it. This is your apparent depth, height, whatever you want to call it. The apparent depth is actual depth or height divided by mu. When you are in rare looking at a denser object, that's where it shifts. And the other way around, if this is the actual height in a rarer medium, this is your apparent height in rarer medium. Apparent height is more. In that case, the apparent height is mu times of the actual height. So this is how the formula changes depending on where you are and where the object is. Street Boy, Game of Thrones, very good. Very good. Yeah, we have board exams and Street Boy watching Game of Thrones. Very nice, Street Boy. Okay, so the next thing, when you have a glass slab of certain thickness and refractive index mu, and you see through the glass slab, then if the object is here, the object appears little bit closer, there is a shift when you see it from this side, that shift happens to be thickness into 1 minus 1 by mu. That is another formula which you should know. Yeah, everybody should know this. All right. So let's move to the next concept in slabs, and that is your lateral displacement. When light rays enter a slab, you will notice that the incident ray is exactly parallel to the emergent ray. It's exactly parallel, but it shifts, and that shift is very visible in this diagram. That's why I have put this diagram up. If this is your incident ray, it shifts. There is a parallel shift. If you look at the deviation is 0. There is only a shift in it. And it all depends on what is the angle of incidence, what is the refractive index, and also what is the angle of refraction. There is a simple formula. You should know this formula also. Look at this. The lateral shift is thickness into sine of I minus r by cos r. Standard formula. Street Boy watched it 45 years ago. Very good. Nice. Were you a part of Game of Thrones 45 years back? Okay. Which character were you? Jon Snow or something else? Okay. So lateral displacement delta x is t sine I minus r by cos r. Okay. So let's start solving the question. Coming up on your screen, based on slabs and shifts, a beaker is of height 21 centimeter. a liquid of refractive index 4/3 is powered. No, it's not powered, guys, it is poured. Oops, blunder. Okay, it's poured, it's not powered. You can't power it. What is T? T is the thickness. Thickness, this thickness, this thickness. Okay, in case you did not realize it, this is the thickness. Okay, T is the thickness, I is the angle of incidence, R is the angle of refraction. Okay, so where are we? A beaker is of height 21 centimeters. The liquid of refractive index is poured to the height h so that the apparent height becomes halved. What is the value of h? Okay, won't T get cancelled? T will not get cancelled. Why will T get cancelled, bachalo? With what will it get cancelled? Nothing is there for T to get cancelled. This is a ratio. This is length. On the right hand side also length dimension should be there. Okay, so let's try and solve this question, guys. So first of all, let's draw the diagram. This is a beaker of a certain height, and the height is given to be 21 centimeters right from here to here. You are pouring some liquid. You are pouring some liquid into this. So the liquid is poured till a height of h. Naturally, the remaining will be 21 minus h. So think as if, you know, this bottom comes somewhere over here. You feel that the beaker has shortened. The depth of this should be equal to, exactly this particular height. It feels that it has been halved. It feels apparently, you know, the height has become halved. So that means this part here and this part here should be same. If this is 21 minus h, even this should be 21 minus h. It feels like, you know, half of the beaker has been filled. Now you just have to solve the problem. This is your apparent height. This is your actual height. Start solving it. Apparent height is nothing but actual height divided by mu. Start solving it. Apparent is 21 minus h. Actual is nothing but h itself divided by mu. Mu is given to be 4/3. So cross multiply. So this will become 3h. 4 will get multiplied here. 4 into 21 minus h. 21 into 4 is 84 minus 4h is equal to 3h. So 84 will be equal to 7h. So h will be 84 by 7, which is nothing but 12. So I have 12 as the option here. Be careful. Actual height is 21, but when you pour that, it feels that the apparent height has been halved. So it feels like, you know, half of it is filled with water. Okay. So basically, actually, this should have been better mentioned this way. Okay. If you're not able to understand, it feels it is half filled, or rather I would put it this way. It feels that apparently it is half filled. It feels that it has been half filled. So this would be a better statement to describe the problem. Okay. So this was actually the statement, guys. So in case you're not able to understand, okay, this was the actual statement. Think of it this way. When a liquid is poured into it, it feels that apparently it has been half filled. So apparently if it has been half filled, that means whatever is there on the top is there at the bottom. So basically this and this should be the same. Okay, I hope this is clear. Is that understood now? Is that fine? Okay, fair enough. Yes. So it's a wrong statement, I would say, or I would say that, you know, it was little bit misleading over there. So probably that's why some confusion happened. It feels that, you know, the entire height becomes half of 21. No, if that can never happen. For no depth, it can never happen, guys. You can never get it over here. That's not going to happen. Okay. Is that clear? Fair enough, Janani. Look at this statement like this. The beaker of this height, you pour some water. So it feels that apparently it is half filled. That means when you look at it from the top, it feels that this water, this liquid is half filling this beaker. because now you won't see the bottom here, you will see the bottom here. So whatever is there this much will be equal to this much. So if this is 21 minus h, this is also 21 minus h. Fair enough, Janani? Everybody clear? Okay, fair enough. Cool. So let's move on to the next question. Coming up on your screen, maximum lateral displacement of a ray of light which is incident on a slab of certain thickness t is. What should be the maximum lateral displacement of a ray of light which is incident on a slab of thickness t? Okay, let's draw the ray diagrams. Let's draw the ray diagrams. I think from that it will be clear. Okay. Now, what happens is, if you notice an incident ray which enters the slab, it bends and it comes out. Obviously, there is some amount of lateral displacement. When do you think the maximum lateral displacement will occur? Obviously, not for normal incidence. I think I should increase the angle. If I increase the angle, then it will get bent more and it will shift more. So imagine this. This is your glass slab and your ray almost is coming like this, almost at 90 degrees. It bends and then when it comes out, it comes like this at a very large angle. You can see the shift literally over here. This is your shift. This is basically your shift. Just mentally simulate this. Increase the angle. This will also go like this. Lower this angle. Okay, basically increase this angle of incidence. Lower this ray. You will see this ray shifts here. Can you see how much approximately the shift is? Can you see approximately how much the shift will be? It's almost going to be the thickness of the slab. Hence, you will notice it should be option D. Yep, it should be option D, my warriors. Yep. Got it? So visualize this. There is no formula requirement. They can ask these kind of conceptual questions in competitive or, CET exams. So it was just about visualization. No formula required over here. Next question. Find the location. Find the location of the image if the slab of thickness 3 cm is silvered behind. Okay, what it means is that this part you have silvered it, meaning it's like a mirror. Now the question is, where will you find the image? Now whenever you see these kind of questions, especially a slab being silvered, the first thing that should come to your mind is that a mirror replicates whatever is in front behind of it. A mirror replicates whatever is in front behind of it exactly as it is. So first of all, forget that there is a mirror. Just ignore and just replicate this same slab behind it. Just replicate the same slab behind it. Now you got a bigger slab. Each slab was 3 centimeters. So totally you got 6 centimeter slab. And now you are going to also take this object and put it behind over here. You're going to take this object and put it behind over here. First of all, think about it this way. How much is this distance? How much is this distance? This is 20. This is 3 centimeters. So this is 23 centimeters. Remember, whenever you have a mirror and you remove it, whatever is there in the front, you put it behind. So you take this object and put it right over here. So now imagine you have an object here and this is 23 centimeters. Now just think of it this way. You are seeing this entire setup through a big glass slab and the object is here. Just visualize it that way. What is 1.5? 1.5 is the refractive index, Mohit. It's just the refractive index. Okay, so you're just observing that object which is behind that slab, but a thicker slab, and this object is over here. So what will happen? It will get shifted, right? It will get shifted, right? This object will shift. And how much will that shift be? I just gave you that formula. The shift will be thickness into 1 minus 1 by mu. The thickness is the big thickness, which is 6. 1 minus 1 by mu. Mu is 1.5 or 3 by 2. So this will be 6 into 2 by 3. 1 minus 2 by 3 is 1 by 3. So this will be just 2 centimeters. So the shift is going to be 2 centimeters, meaning from the mirror, how much will this distance be from the mirror or the silvered side? How much will this distance be? This is 23, this is 2, 23 minus 2. This will be 23 minus 2, which is 21 centimeters. So you will see that the final image will be just formed over here. That's it, it's very simple. So whenever you see such silvered glass problems, forget the mirror, forget the silvered side. What's there in the front, repeat it behind. And now look at it like a normal problem. Oh, there is a slab and there is an object behind. So it will shift. And the shift formula you know. Once you know the shift and you know the actual original distance, you can do plus minus and get the answer. Why not 23 plus 2, Mohit? Okay. See, whenever you have a glass slab and the object is behind, the object never shifts away. The object always shifts towards you. Things are got closer. You always get it closer. So that's why it is 23 minus 2 is 21. Okay, got it? Hello, Kriti. So feel, all we have done is, this was a slab, this was silvered. So what you did, you just replicated it behind. When you open it, the slab also doubles. The slab also doubles, it opens up. 3 will become 6. This object will come here. This was 20, this was 3, this is 23. So you will see it at a distance of 23. So when you look at an object through a slab, what will happen? It will come closer. You just figured out how much closer it came. That's all. Okay, so good question. Everybody understood? Divyansi, after probably board exams. Okay, let's go to the last part of today's lecture, and that is basically, lenses. Convex and concave lenses. Again, when you have concave and convex lenses, and before, you should remember that they are actually two surfaces on each side where light refracts twice. So if you take any one surface of a lens or any curved surface, the formula for the light bending or where the image is formed is given by, okay, probably I have it over here, yes, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. What are these mu2s, mu1s, r's, v's, u's, etc.? See, for example, just imagine this. Let's say, for example, you have a glass sphere and maybe some ant is trapped over here. This sphere has a radius r and refractive index 2, example, and you are seeing that ant from here. When you look at that ant which is inside the sphere, the ant won't be seen exactly at the same spot. It might be seen maybe closer or farther. This is the image of the ant. The first things first, the point over here, which is along the axis, this point is called as the pole, okay, where the interface changes and you are along the principal axis. That point which is on the interface and on the principal axis is the pole. All distances are to be measured from the pole. Okay, all the object distance, image distance has to be measured from the pole. What is mu2, mu1? Is the refractive index of both the medium. Is the refractive index of both the medium. So mu2 is always the refractive index where the refracted rays, and mu1 is always the refractive index where the incident rays. R is the radius of the surface where the refraction occurs. Mu2 and mu1 are the refractive indices of the respective medium. Mu2 for refracted, mu1 for incident. So you only think and tell me, in this case, what is mu2 and what is mu1? Come on, let's see how many of you can answer this. Come on guys, think and tell me. Think and tell me what is mu2 and what is mu1 in this case. If you just know that, rest is just formulas. You can just apply object distance, image distance formula. You will get the answer. Just tell me what should be mu2, what should be mu1. Just look at the rays. How will the rays go? The rays from the ant will come like this and they will go like that. This is where the incident ray is. Incident ray is in mu is equal to 2 medium. So mu1 will be 2. Mu2 will be 1 because it is in air. This is for that glass or whatever. Mu2 is in air. Correct. Mu2 is not sphere. Be careful. Understood? So always look or remember mu2 and mu1 not as left, right or top, bottom. No, that's not the correct way. 2 is the second ray, refracted. 1 is the first ray, which is the incident ray. You can see the rays from the end are initially in the sphere medium. That has a refractive index 2, so mu1 is 2. Got it? Everybody clear about this? Fair enough? Alright. So that's the refraction at a single curved surface. But when you have two curved surface, it becomes a lens. And you can have concave, convex lenses. And let's look at their formulas. Yep. Mu2 is the medium, mu1 is air. IT aspirant, don't by heart like this. What I told you, always look at mu1 is incident, mu2 is refracted. Remember it like that. Yeah. Incident is mu1, correct. Incident is mu1. So you can see this is your incident ray. The rays from the object are incident like this and they get refracted here. These are the refracted rays. This is your incident ray. This is your incident ray. Fair enough? Okay. Now, quick reminder. For a concave lens, the focal length will be, for a concave lens and for a convex lens, what will be the focal length? For a convex lens, you can see, okay, my God, it's changing again and again. All right, so I'll just put it over here. So for a convex lens, the rays actually merge, hence the focal length will be positive. Whereas for a concave lens, it will be negative in nature. Yeah, it will be negative because the rays diverge, the focal point is behind the lens, like you can see over here. Now, once you know this, you should also know the simple rules for drawing ray diagrams, which are again very much similar to the ones which you have learned in case of mirrors. Like the rays parallel to the principal axis meet at the focal point, rays passing through the focal point become parallel, and there is one more important rule, that is if a ray passes through the pole, it goes undeviated. If a ray passes through the pole, it goes undeviated. This is your another important ray diagram rule for lenses. Please keep that in mind. Okay, I hope this is clear. My God, again you guys are asking something. Mu2 medium, mu2 is medium, mu1 is air. No, nothing like that. Mu2 is refracted, mu1 is incident. That's how you're going to remember, Janani, Mohit, everyone. It changes from problem to problem. Like for example, let's take this example only over here. This is also curved surface. This is also curved surface. Let's say you consider one of the ray here. It bends and then again bends. Okay. Now, if you take this surface, this is your first surface. For the first surface, what will be mu1? What will be mu2? Think about it. What will be mu1? What will be mu2? This is the incident ray. This is the refracted ray. This is incident, this is refracted. Correct? Okay. Incident is in air, so this is for air. Mu2 is in glass. Mu2 is in glass. That's where it is refracted. So you will have the refractive index of glass. Fair enough? Now, for the next refraction, which is occurring over here, for the second refraction, this is also curved surface. But for that, this is the incident ray. So for that, mu1 will be for the glass and mu2 is in air. So that will be the refractive index of air. Is that clear? Okay, do not by heart it dense rare. That's not correct. Always remember 1 is incident, 2 is refracted. That's when you will never ever make a mistake. Okay, so let's look at the lens maker formula. So if the radii of curvature of lenses are known, like for this lens, this is R1 and this radius of curvature might be R2. Similarly over here, you can figure out what is the focal length, and the formula is 1 by f is equal to mu minus 1 into 1 by R1 minus 1 by R2. This is your formula. R1 and R2 are the radius of curvature of the two surfaces in order. Yeah, this is something which you should know. Now many people feel, sir, How do I know which one is R1, which one is R2? This is a common question. So I have a question for you. If I have a plano convex lens, okay, and the light rays are coming like this, bending, whatever, and they are meeting here. This is basically the first surface. This is your second surface. Correct? This is your first surface, this is your second surface. The first surface will have infinite radius of curvature because it is flat. The second surface will have some radius of curvature. Everybody agrees to this? Okay. What if I take the same lens and make it like this? What if I take the same lens and I make it like this? Now will the focal point change or will the focal length change? Because now this will be R1 and this will be R2. R2 will be infinity because this is flat. In this case, whatever focal length you get, and in this case, whatever focal length you get, do you think it will be same or different? Let me know in the chat box. What do you guys say? Is it going to be same or is it going to be different? Okay, I'll give you a simple logic. Look at this. If you use lens maker formula, 1 by f will be equal to mu minus 1. 1 by R1. What is R1? R1 is infinity, right? Minus 1 by R2. R2 is the radius of curvature, but the center is here. So think about it. This is the positive side, this is the negative side. So strictly speaking, R2 will be minus R. R2 will be equal to minus R. Think about it, because for this surface, the center is over here. So it is on the negative side. So all that matters is the center of curvature. Okay, a lot of you are saying signs will be different. Okay, let's see what's the answer. So this will come out to be how much? Mu minus 1. Minus becomes plus. 1 by infinity is 0. So this will become just 1 by R. Okay, this is the focal length. 1 by f focal length is coming out to be mu minus 1 by R. Take for the second case. R1 for this surface, the center is over here. Look at this. The center of curvature is here. So R1 is plus R in this case. So 1 by f will be mu minus 1 by R1. So 1 by R minus 1 by infinity. It comes out to be again mu minus 1 by R. What does this tell you? The answer is same. Even the sign is same. A lot of people make this mistake thinking when you reverse the lens, the focal length reverses the sign or some magnitude changes. Wrong. You take any lens, not just plano convex. You take concavo convexo, convexo convevo, convex, concave, biconcave, whatever you take, it will always remain the same. So the order does not matter. It's the same. It's same in magnitude, same in sign. Keep this in mind. Got it? Understood? Perfect. Shall we move ahead to the next one? Okay. Power of a lens. The power of a lens is just 1 by f. There is no negative sign. The negative sign was there in case of mirror. Hello, Srishti. Okay. Next, the lens formula. It's very similar, but again, sign difference only. 1 by v minus 1 by u is equal to 1 by f. You can note the negative sign. In case of mirror, it was plus. The magnification formula will be plus v by u. There is no minus sign. Wherever there was minus, it's a plus. Wherever there was a plus, there is a minus. Next, for the magnification along the longitude, this was image height by object height. This will be v square by u square, which is the image width by object width along the principal axis. So there is no minus sign. That's how you can remember it. Same formula. So if you remember mirror, you know the lens formula also. And you should know where the images are formed for different places. So you can try it out. You can draw the ray diagram. Do not by heart it, but this should be like your reference sheet. You draw the ray diagram for each and every point. Only then you will get a feel. Okay, if I show it to you, there is no point. But I have placed it just for you so that you can refer this and proofread whatever you have done. That's all. So I just gave you the lens formula. Let's start doing the questions on this. Coming up on your screen. The refractive index of a material of a plano convex lens is 5 by 3. Radius of curvature is 0.3. What is the focal length? Let's try and solve this. The radius of curvature is given, material is given, what's the focal length? I just told you, it really doesn't matter how you place the convex lens. You can place it in any order, you will get the same thing. Now, this is your plano convex lens. Okay, so your focal length formula 1 by f will be equal to mu minus 1 by r1 minus 1 by r2. So mu is nothing but 5 by 3 minus 1. Now what is r1 and what is r2? See, this is your first surface. The first surface center will be here. This is C1. This is your second surface. The second surface has radius which is infinity because it is flat. This is negative side if the rays go like that. This is your positive side. Naturally, from this diagram, C1, because it is on the positive side, radius of curvature 1 will be also positive, and the radius is given to be 0.3 in magnitude. The sign came by drawing and visualizing. Without that, you will not be able to guess it properly. You will make some kind of silly mistake. So 1 by R1. R1 is plus 0.3 minus 1 by R2. R2 is infinity. 1 by infinity is 0, so don't bother. 5 by 3 minus 1 is 2 by 3 into 1 by 0.3 will be remaining over here. So this will become F is equal to 3 into 0.3 divided by 2. 3 3s are 9, 9 by 2, 4.5. So it will become 0.45. That should be the answer. Just check this out. Is it there? Yep, option A. But since it is, what is it? Plano. Oh, guys. What did I just do? I solved it for a convex lens. I'm so sorry. It was concave lens. I'm so sorry, guys. This is a concave lens. So whatever I did, everything you have to put a minus sign. Everything you have to put a minus sign. All right. So let me just erase everything. So my first diagram only was wrong. It was a plano concave lens. So anyways, now you know how to solve for a convex lens. So if it is a concave lens, just draw this diagram, and this will be your R1, R2 will be infinity. This is your negative side. This is your positive side. R1 is given to be 0.3, but sign wise it will be minus 0.3. So again, when you use your lens maker formula, which is 1 by F is equal to mu minus 1 by R1 minus 1 by R2, mu is 5 by 3 minus 1, R1 is nothing but minus 0.3, R2 is infinity, so this will become 2 by 3, correct, into 1 by infinity is 0, forget it, so this will be 1 by minus 0.3. So naturally F will be 3 into minus 0.3 divided by 2, 3 3s are 9, so it will become minus 0.45 because 9 by 2 is 4.5. Yes, just the sign will be different, so option A will be correct. Option A will be correct. Got it? That's all. But I wanted you to see how things change if it is a plano concave or plano convex. Now you can never make a mistake in sign because we have done all kinds of problems, guys. Okay, shall we move ahead to the next one? Next question coming up on your screen. A thin lens made of a glass of certain refractive index has, doesn't make sense, front surface power, no, has a power of 11 diopters and, okay, I think there was some mistake over here. No, this was not there, guys. There is some printing mistake. A thin lens made of glass has a refractive index this much and a power of 11 diopter. Now this lens is submerged in liquid of some refractive index. Okay, then the resulting power of the lens, I don't think this, anyways, let's see. Let's solve this question. The thin lens made of glass of this much refractive index has 11 diopter power. Now, if you immerse it in some liquid, okay, if you immerse it in some liquid, I don't think this refractive index was given. I had changed the question. Okay, this refractive index was not given, guys, in some unknown liquid. I'm not sure where that modified question went. Then the resulting power of the lens is how much? The resulting lens's power can be how much? Okay, so if you look at the focal length formula, which is mu minus 1 into 1 by R1 minus 1 by R2, this mu that you see Is it absolute refractive index or is it relative refractive index? This is always relative refractive index. This is always relative refractive index. Keep this in mind. Now, when you are in air, what will happen? Mu relative will be more than 1. When you are in denser medium than the lens material, then the mu relative will be less than 1. When you are in a similar medium, then the relative refractive index will be 1. That means this number that you see over here, mu minus 1, this number, mu minus 1, in the first case will be positive. In the second case, mu minus 1 will be negative. In the third case, mu minus 1 will be 0. So, this entire number can be positive, negative or 0. That means the focal length also has 3 possibilities. It can be positive, negative or even 0. All 3 possibilities are there. Hence, the power can be also positive, it can be negative, it can be also 0. So, all possible options are possible. Hence, the answer will be, I don't know where it went. Yeah, see, this is where the question was. This is the actual question. A convex lens has a power of 2 diopter. Now it is immersed in an unknown liquid. What are the possible values of the power? So, I had put that question, but I think it got modified by some reason. Anyways, this was the actual question. So answer is everything is possible. 0 means if the focal length is 0, what does it mean? If the focal length is 0, it means the power is infinity. Power is infinity. That means crazy, right? It can converge it almost at that point. 0 focal length. Okay, so all ranges are possible. Okay, so that's what it means. All right, so let's see the answer. Yeah, like you can see, everything is possible. All right, next question. A concave lens of focal length 20 centimeters is placed in contact with a plane mirror and acts like a convex mirror of focal length. How much? Interesting question. Okay, let's solve this. So concave lens, a concave lens of focal length 20 centimeters is placed in contact with a plane mirror. I just told you, whenever you see a mirror, what you should do? You should open it up. So whatever is there in the front, just put it behind. Just forget that there is a mirror. Later on, we'll put it back. Open as it is, solve, analyze, get the answer, and then put it back. That's what you should do. So the question is, what is the focal length of that mirror? All right. So first of all, we know that if the rays come like this, they will diverge and they will further diverge over here. So what will be the effective focal length? Just what will be the effective focal length of this entire combination? It will be 1 by f1 plus 1 by f2. When mirrors and lenses are in contact with each other, the reciprocals of the focal lengths get added. So the focal length of this concave lens is 20 centimeter. So think about it. It's a concave lens. So that means the actual focal length should be negative, right? It should be negative. So minus 20 plus 1 by minus 20. So this is minus 2 by 20, which makes it minus 1 by 10. Hence, the effective focal length is minus 10 centimeters. Now, this effective focal length that I got was assuming the rays are going like that, continuing in the direction of the incident rays. But I know one thing, the rays don't continue in the same direction. Actually, there was a mirror. In my head, I have opened that complete diagram. So actually what is going to happen, these rays after hitting here, they are going to come like this. They are not going to go like that. They are going to come back here, reflect it. They are going to come like that. If they are going to come like this, what is it behaving like? What is it behaving like? The rays are diverging. It is behaving like a convex mirror. It is behaving like a convex mirror. So the focal length magnitude is the same of that convex mirror. The magnitude is the same as the effective focal length, but just that it should be positive, because for a convex mirror we know the focal length should be positive. So hence it will be modulus of -10, which is just 10 centimeters. It's a convex mirror. See this. Why is it a convex mirror? The rays were diverging. When you flip it back, it comes here. So still the rays are diverging. So now I realize, oh, the parallel rays diverge. So it should be convex mirror. And for a convex mirror, the focal length is positive. So make it +10 magnitude wise. That's it. Hence you get answer as option A. Perfect. Great, guys. All right. So last question, I guess. A convex lens of certain focal length, 30 centimeter, produces 2 times magnified real image of a cylindrical object whose axis coincides with the principal axis. What is the magnification of its volume? This is going to be one amazing, crazy question. Let's solve this. What do we have? We have a convex lens of certain focal length. Okay, we have a convex lens of certain focal length. Along the principal axis, we have a cylindrical object whose axis coincides with the principal axis. So this is how it is. There will be some radius, there will be some length. If the magnification, the image magnified is 2 times, meaning given this magnification is 2, what is the volume magnification? Because I know this cylinder's magnified image will be produced over here. A magnified image will be produced here. Correct? So radius will also change, even the length will change. First think about it. When I talk about this magnification, am I referring to the radius or the length? This magnification is the one which is perpendicular to the principal axis. For this diagram, the radius is perpendicular to the principal axis. Hence, you will notice this is the image radius by the object radius, which is given to be 2. Fair enough? Great. Next, if I know that this magnification is 2, I know one more thing. The magnification which occurs along the longitude is v square by u square, where v by u is just this magnification. So it's just the square of that. So if the lateral is 2 times, the longitudinal will be the square times, that means 2 square, which is just 4. So the length along the principal axis, length of the image upon length of the object will be 4 times. Fair enough? Next, the question is about volume. The question is about volume. Volume of the image upon volume of the object will be, what is the volume of a cylinder? Cross-sectional area into the height. Cross-sectional area will be pi r square, so image square, into height is the length, upon pi r o square, length of the object. Pi cancels. I am left with ri by ro whole square into li by lo. Notice I already have the value of ri by ro. Ri by ro is 2, so 2 square. Li by lo is nothing but 4 times. 2 square is 4, 4 into 4 is nothing but 16 times. It's 16 times, not 8 times. Hence the correct answer should be D. Hence the correct answer should be D. Got it, everyone? Perfect. So this is a beautiful question on volume, and volume has to be calculated by area into length. Area is pi r square. So this r is perpendicular to the principal axis. So we use magnification formula, which is v by u, or height by height of the image by height of object. For this magnification, I know it is square times. So square means whatever this magnification is there, you square it, you get the lens magnification. That's it. Rest is just simple math. It's a beautiful question, guys. Okay, so in case you are preparing for CUET exam, we also have the CUET crash course. So it has all the subjects covered, all the important subjects which you would need: physics, chemistry, maths, bio, GK, even mental ability, English, all the languages, whatever you would need are there with classes which are starting right from 18th April. You can watch the recordings, assignments as well as the test series, and you will get this crash course for CUET exam, which is a Central University Entrance Exam for all the government funded colleges apart from IITs and NITs. I made a special lecture on that. The crash course is just for 5,400, but if you are okay with physics, chemistry, maths, and maybe you just need help in English, current affairs, mental ability, numerical ability, etc., then the crash course is just for 2,475. Link is there in the description box. Go ahead, check it. Join the Telegram channel because that's where you get the entire PDF. Thank you for watching, guys. And I know it was a lengthy session, very interesting session, but I know even if you got tired and maybe you lost track, it's okay. You can watch the replay later on. Okay, that's it. Thank you guys very much for joining in. And if you have some questions and if you have any doubts, please let me know. Oh, Naz. Okay, I will do. I'll do right away. Okay, fine. Definitely, Naz. Take care, guys. Bye bye. Have a great time. This was Captain Shreyas signing off. Hasta la vista.